What if a sculpture didn't just sit still, but breathed, rotated, swayed, or responded to the world around it? This is where art leaves stillness behind and enters the realm of motion. Welcome to the world of kinetic sculptures, where creativity meets physics and movement becomes meaning. Kinetic sculpture is a form of art that depends on motion for its full effect. Unlike traditional sculptures that are frozen in time, kinetic works are designed to move. Powered by wind, motors, magnets, gravity, or even human interaction, the movement isn't just decorative. It is the artwork.
Behind every moment lies a scientific wonder. I'm Kale, and welcome to SciCurios, where curiosity meets science.
The idea of moving art gained momentum in the early 20th century, alongside rapid advances in engineering and industrial technology. Artists began asking a radical question. If the modern world is defined by motion, machines, engines, cities, and flux, why should art remain static? From a scientific perspective, kinetic sculpture is a living demonstration of classical mechanics. Every rotation, swing, and oscillation follows physical laws first formalized by Isaac Newton. When a sculpture spins, it obeys rotational motion. When it sways back and forth, it behaves like a pendulum, governed by gravity and restoring forces. Nothing in a kinetic sculpture moves randomly. Every motion has a cause. One of the most elegant forces used in kinetic art is wind. Wind-driven sculptures rely on fluid dynamics, the branch of physics that studies how air flows around objects. When wind passes over angled surfaces, it creates differences in pressure. Those pressure differences generate lift or torque, causing parts of the sculpture to rotate. Even a gentle breeze can be enough if the artist carefully balances mass, shape, and friction. Balance is crucial. Many kinetic sculptures are finely tuned systems operating near equilibrium. A small force produces visible motion because friction is minimized and weight is precisely distributed. This is why some sculptures seem to float or move effortlessly, even though they may weigh hundreds of kilograms. Other kinetic artworks rely on motors and electromagnetism. Electric motors convert electrical energy into rotational motion using magnetic fields. In these sculptures, timing circuits and control systems determine speed, direction, and rhythm. What looks like artistic choreography is often the result of engineering calculations: voltage, torque, resistance, and load. Magnets themselves can also be part of the motion. Magnetic repulsion and attraction allow parts of a sculpture to hover, vibrate, or shift without direct contact. This reduces wear and creates movements that feel almost impossible, like objects moving without being touched. Materials science also plays a silent but vital role. Metals must withstand repeated stress without fatigue. Bearings must reduce friction. Lightweight alloys allow larger structures to move safely. But kinetic sculpture is not just about physics, it's about perception. Humans are biologically wired to notice movement. Our visual systems evolved to detect motion as a sign of life or danger. When a sculpture moves, it immediately captures attention, holding it longer than a static object ever could. Motion also introduces time as a dimension of art. A kinetic sculpture is never experienced the same way twice. Its appearance changes with lighting, airflow, viewer position, and duration of observation. Some kinetic sculptures respond directly to viewers. Sensors detect proximity, sound, or movement, triggering mechanical responses. In these cases, feedback loops, systems where output influences future behavior, become part of the art. This blend of art and science challenges the traditional boundary between disciplines. Engineers must think aesthetically. Artists must think mathematically. Kinetic sculpture exists precisely at that intersection. In a world increasingly shaped by automation, algorithms, and machines in motion, kinetic art reflects our technological reality back at us, sometimes playfully, sometimes critically. It asks us to slow down, observe motion carefully, and appreciate the invisible laws that govern both art and the universe. So the next time you see a sculpture that moves, ask yourself, is it art powered by science or science disguised as art? What kind of motion do you find most fascinating? Wind-driven, mechanical, magnetic, or interactive? Share your thoughts in the comments.
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.